In this video, I'm going to do a couple more examples of employing the chain rule by first writing the function as a composition and a definite inside and outside function. G is the inside, F is the outside, and then applying the chain rule. So what I will do is, this may not look like a composition at first, but remember that when we write the power there on a trig function, this is the same as saying cotangent of x all raised to the fifth. So now we have an inside and an outside function. So when we go to identify an f and a g, the inside function is just going to be cotangent of x. Now that leaves for the outside function, remember, replace that with an x to the fifth. This breakdown is nice for getting used to the chain rule. So f prime of x is 5x to the fourth. G prime of x, the derivative of cotangent, is negative cosecant squared x. I'm going to put back together f prime of g of x, which means I'm going to put g into my input for f prime. So 5 times the cotangent of x to the fourth, or writing it the way we had written it earlier, 5 cotangent to the fourth of x. Now we can multiply to get our chain rule. So z prime of x is 5 cotangent fourth of x times negative cosecant squared x. But a lot of times we'll write that negative out front so we don't confuse it for a minus. So negative 5 cotangent to the fourth of x times cosecant squared x. And there's our derivative. Let's just do one more here. M of x is equal to the secant x e to the x all to the ninth. Anytime you have something like this inside parentheses raised to the exponent, it makes it a little bit easier to identify our inside and outside, because our inside function is going to be what's inside those parentheses, which is secant x plus e to the x. That leaves our outside function as a very simple x to the ninth, which also leads to a very simple derivative. F prime of x is 9x to the eighth. G prime of x is going to be a piece-by-piece derivative. The derivative of secant x is secant x tangent x. And we got our easiest derivative. The derivative of e to the x is just e to the x. Again, last step is to plug back in our composition. F prime of g of x is going to be 9 times what g of x is, secant of x plus e to the x all to the eighth. We now have our m prime of x via the chain rule, which is 9 times secant x plus e to the x all raised to the eighth. Now times g prime of x, which we'll want to put in parentheses, secant x times tangent x plus e to the x. And there's our derivatives using chain rule.